Hello, this is Mr. Wynn, and this video is about dividing polynomials. Hopefully you know that division is the inverse operation of multiplication. They undo each other and act as opposites, and you'll see the main word quotient. So for example, since we know 2 times 3 is 6, we can go backwards. The answer 6 divided by one of the factors will give us the remaining factor. So 6 divided by 2 is 3, or even 6 divided by the other factor, 3, is going to give us 2. And we don't use the division sign anymore. We usually make it a fraction. So it'll like this: 6 divided by 2 equals 3, or 6 divided by 3 equals 2. Alright, so we don't really use this division sign too much. Alright, that also applies to the bottom for letters, polynomials. So if we know x plus 4 times 2x plus 5 equals 2x squared plus 13x plus 20, that's after foiling and combining terms, then we can undo it or go backwards. The answer, 2x squared plus 13x plus 20, divided by one of the factors, in this case x plus 4, will give us the remaining factor, 2x plus 5. Or we can go backwards the other way, 2x squared plus 13x plus 20 divided by the other factor, 2x plus 5, gives us x plus 4. And again, we show it as a fraction, we don't use the division sign. Alright, so the easy case, dividing by one term. If you're dividing multiple terms by one term, just split the big fraction up into multiple fractions and reduce where possible. So for this first example, it's these 4 things on top, divide by the single term, 2 on bottom. I'm going to divide this fraction to multiple fractions. The first thing over the bottom, plus the second thing over the bottom, plus the third thing over the bottom, or minus the fourth thing over the bottom. And reduce each where possible. 12 divided by 2 is 6. X cubed stays x cubed. 4x squared, 2x minus 8. That is the answer. Alright, pretty simple. Same thing over here. There could be a letter on bottom, but the same idea. Split it into multiple fractions. So the first thing over the bottom, plus the second thing over the bottom, plus the third thing over the bottom, minus the fourth thing over the bottom. So everything on top, divide the one thing on bottom. Reduce where possible. 12 divided by 8, I can divide top one by 4. That's 3 over 2. And then x cubed divided x to the first is x squared. See, plus 8 divided by 8 is 1. And then x squared by x is x, so 1x. Plus 4 divided by 8 is 1/2. And x by x is 0, which is just 1. It goes away. And then 16 by 8 is 2, but the x is on the bottom. That's the final answer there. Alright, just if we divide by one thing. If you divide by multiple things, that's the harder case. So multiple terms by multiple terms, you have 2 options. You have long division or synthetic division. The good news is long division follows the same steps you learned in elementary school, and it'll work for any problem. So let's do a quick old example. So what is 9,260 divided by 3? So you learn to make this little chart. 9,260 divided by 3. And you always ask the question, how many times does the outside number, does this 3 right here go into the first number 9? So 3 goes into 9 3 times, because 3 times 3 is 9. I usually go backwards. I say, what's 9 divided by 3? I get 3. So whatever's on top multiplies the number on the side. So 3 times 3 is 9. Then you draw a line. Now, although they're both positive 9s, I don't say 18. I'm going to subtract. There's an invisible subtraction sign. Let me put it in black right here. So that makes me do 9 minus 9, which gives us 0. From there, you're going to bring the next term down. So if how many times does 3 go into 2? Well, 3 doesn't go into 2, so we put 0 times. We're going to multiply the top number I just wrote, 0 times the outside number 3. 0 times 3 is 0. Draw this line, and again, it's the opposite. I'm going to subtract. When you add or subtract, it doesn't matter. So 2 minus 0 is still 2. Use what color? Let's use red. Alright, then I bring on the next term. 6. I forget how many times is the outside number? 3 going to 26. But I divide 26 by 3, I get 8. So I put this number up here, 8. Whatever's on top, multiply the side. 8 times 3 is 24. And although they're both positive, I'm not going to positive 50. I'm going to do the opposite. I'm going to subtract. So 26 minus 24 is positive 2. Bring on this last number. How many times does 3 go into 20? Well, that is 6 times. Alright, so 3 times 6 is 18. And I'm going to do the opposite. I'm going to subtract. That makes this a 2. There's something else to bring down. That last number is called our remainder. The remainder, we don't write R2. We're going to do a fraction. 2 over whatever's on the outside. We're finding thirds. That is our final answer. So 3,086 and 2/3 times 3 will give us 9,260. Alright, so same idea over here with letters. What is that? Divide with that. It's the same problem as before, so we should know the answer already. We're going to make the same house. Now, when you have multiple letters, we actually don't care about multiple letters. We want to care about the first thing. So I'm going to ask, how many times is x, this first thing? So we're checking how many times does this x, this first thing on the outside, goes into this first thing on the inside, go into 2x squared. So I'm going to go backward and divide. What's 2x squared by x? Well, that's just 2x. So x goes into 2x squared 2x times. So whatever's on top multiplies the left side, the outside. Now this 2x must attribute to both things. So 2x times x is 2x squared. And 2x times positive 4 is positive 8x. I draw my line, and they both look positive, and we're doing the opposite. So I just know in my head that on the bottom, all the signs change. So 2x squared minus 2x squared is 0x squared. They cancel out. They're supposed to cancel out. And then positive 13x minus 8x is positive 5x. All right. Then we're going to bring down the next term. This is positive 20. And we'll repeat the process. I'm going to check how many times does this x right here go into the first thing, 5x. If you divide 5x, divide x, you get positive 5. So x goes into 5x 5 times. Whereas on top, multiplies the side. So positive 5 times x is positive 5x. Positive 5 times positive 4 is positive 20. Then I do the same process, and then they're both positive. I need to do the opposite. If they're matching, they're going to disappear. All right, 5x minus 5x cancels out to 0. 20 minus 20 is also 0. There's nothing else to bring down, so that 0 is our remainder. If the remainder is 0, you can skip that. So our final answer is 2x is 5. So we know 2x squared plus 13x plus 20 divided by x plus 4 equals 2x plus 5. If we go back to the other side, it is right here. It's this one. All right, so that's how you do long division. All right, the other method is called synthetic division, and that's a shortcut method that can only be used when we're dividing a polynomial by a linear factor. If you divide by anything else, if you divide quadratic or cubic, then you must use long division. All right, now, if it's linear, we need a shortcut method. There are the 6 steps, but get used to them really fast. The first one is check for missing terms in descending degree order. What I mean is, look at this first term, thing that we're dividing, the polynomial. The degree is 2. The number of terms is always 1 more than the degree. So 2 plus 1 is 3. There should be 3 numbers there. There's the x squared term, an x to the first term, and a constant term. So that's good. If one of those are missing, I have to put a 0 for them, which will be on a different example. Also make sure you're going down descending order. You show x to the highest power, followed by the next x to the highest power, followed by the next thing, all the way to the constant. That's step 1, done. Step 2 says solve the dividing factor for the root and put in the corner box. This is the dividing factor. We're going to solve that. We're going to say x plus 4 equals 0. You solve for x. That's easy. Subtract 4, subtract 4. Okay, x equals negative 4. That is our number that goes in the box. Let's see. I'll use green. So there's a box, negative 4. The third step is create the chart. The chart has the coefficients of the polynomial next to the box. So the numbers from the polynomial is positive 2, that's in front of x squared. Positive 13 is in front of x, and positive 20 is the constant. You just skip a line, a row, and draw a line. And now we do the very fun process. All right, it says bring the first term down below line. So this 2 will go down here, stays positive 2. And then use the pattern. I always say add down, multiply across, but technically any number below the line gets multiplied by the number in the box and placed diagonally across. So since 2 is below the line, I'm going to do 2 times negative 4. I get negative 8. I place it across. Then I'm going to add downwards. 13 minus 8 is positive 5. 5 is below the line. That has to multiply the number in the box, negative 4. So 5 times negative 4 gives me negative 20. That goes across. I'm going to add down. 20 minus 20 is 0. All right, that last number is the remainder. If the remainder is 0, that's really good. Now, last thing says write the final answer correctly. The numbers below the line are the coefficients of the answer, which must be 1 degree lower than the problem we divided. So we start with a quadratic, degree 2. Our final answer is linear, degree 1. So put those numbers next to the appropriate letter and exponent. So this first 2 was in the x squared column, but it goes down. So this first 2 in our answer goes with 2 to the x to the first power. This was the x to the first column, but when you go down one letter, it's x to 0. So it's going to be 5 has no letter, and the last thing is a remainder. Sometimes people put like a dotted line here to show you that's a remainder. Right, that's the answer. Alright, so 2x squared plus 13x plus 20 divided by x is 4 is the same 2x plus 5 we got from the last problem. I did the same problem twice, one doing synthetic division, one doing long division. Alright, the last slide. Remember to always check for missing terms or missing zeros. This is required for both synthetic division and long division. There's also a side thing that I usually don't make y'all do, but when doing long division, missing zeros also need to be checked in the divisor, the thing you're dividing by. So to simplify this problem, a lot of people think this is a multiplication problem, but remember the -1 power, you can have a negative exponent. What that -1 does is means I have to move to the bottom of the fraction and make it a positive. So this is actually m cubed minus m squared plus 1 divided by m plus 2. This is a division problem. Alright, so first I'm going to check for the first term, any missing zeros. I see the degree of 3, because it's m to the third power. I don't touch 4. There should be 4 things. There should be m cubed, m squared, m to the first, and no m. I notice that m to the first power is missing, so I have to put a 0 there. So really this is m cubed minus m squared plus 0m plus 1 divided by m plus 2. If I do long division, I need to, or let me do synthetic division first. I'm going to solve the divisor for the root. So m plus 2 equals 0. I subtract 2 both sides. I get m equals -2. So I know -2 is inside my box. Then I write the coefficients. In front of m cubed is a 1. In front of m squared is a -1. For m to the first power is a 0. Zeros are important. Then the constant is 1. Draw the line. Do the process. Drop the first one. Multiply by the number in the box. Add down is -3. Multiply by the number in the box. -3 times -2 is +6. Add downwards. Multiply the number in the box. Add downwards. Alright, then I'm going to put my answer. So this first one goes into the m cubed, we'll go m squared. So 1m squared. Then it goes -3, that goes to m to the first power. And that's +6 with m to no power, the constant. That -11 is our remainder. The remainder, you always write it as a fraction. We're dividing by m plus 2. That's the answer. Alright, let's try long division. So I'm going to make the house, what are you going to call it? Put inside m cubed minus m squared plus 0m plus 1. Again, you need a 0 there or else you mess up. It's about m plus 2. So I'm going to check how many times does m go into m cubed? It goes to m cubed m squared times, because m cubed by m is m squared. We're on top, multiply the side. M squared times m is m cubed. M squared times +2 is +2m squared. Remember, we have to do the opposite, we have to subtract. So really this m cubed is negative. M cubed minus m cubed is gone. That 2m squared is also negative. -m squared minus 2m squared is -3m squared. I'll bring on the next term and repeat the process. So how many times does m go into -3m squared? It goes into that -3m times. -3m times m is -3m squared. This was a match. -3m times +2 is -6m. Remember, I'm going to do the opposite. So -3m squared plus 3m squared cancels out to 0. 0m plus 6m is +6m. Bring down this 1. Repeat the process one last time. So how many times does m go into 6m? Goes there +6 times. 6 times m is 6m. 6 times 2 is +12. We're doing the opposite. So 6m minus 6m cancels out. 1 minus 12 is -11. There's something else to bring down. That is our remainder. So I'm right -11 over the thing we're dividing by, m plus 2. That is the answer. Same answer we got when doing synthetic division, the shortcut. All right, that's the whole video. Hope you enjoyed it. Make sure you ask any questions in class. See you soon. Thanks again. Bye.